Okay guys, welcome back. So now it's time to get this bird chasing the cube. So we're going to click on the bird and we're going to edit the bird controller and add a few lines of code to make the bird follow the target. So I want you to double click on the bird controller script and that will open up MonoDevelop. Here we go. And I want you to come up to the top and we're going to add a private variable. Now, the private variable is going to be a transform, okay, and we're going to call it target focus. Okay, now what that basically means is we're creating a variable that this script can use, and the type of variable it is a transform, so it's expecting one of these items, so basically the x, y and z coordinates of a vector 3. So inside MonoDevelop, when the game first starts, what we want the bird to do is look for the target cube on the scene, and the way that we're going to do that is inside here we're going to say that the target focus variable from up at the top equals, and then what we're going to do is we're going to find a game object and we're going to find the object by the tag, which is why we tagged the cube in the first place. So there's an inbuilt function for this and it expects a string which is the name of the object. So if I just press return, a string, if you remember from the previous videos, is in between quotes. Now just to make sure I get the name exactly right, if I click on the target focus, the tag is target lowercase in my particular case. Now make sure, because it's case sensitive. Okay, now the bird will now know what the target is. So the first thing that we need to do is then create something called a vector 3, which will effectively draw a line from the bird to the target, and using this vector 3 we can then work out the distance to the target, and we can also get the bird to fly towards the target along that line of sight. So let's come down into the update statement, because this is where we want to add our vector 3. So a vector 3, if you remember, it's just a line. There we go. And I'm going to call it target, and this vector 3 will equal the distance from the object to the bird. So the way that we draw a line, it's invisible by the way, we're not going to actually see this line, but the way that we do this is by getting hold of the target focus position. So if you remember, the target focus is a transform which has a position, rotation and scale. So when I type in target focus, I can then put a full stop and I can go after the position, the rotation or the scale. And what I want to do is from that point draw a line back to the bird, which in this particular case, because this script is attached to the bird game object, we can use this, get the transform for this game object, and then we can access the position of this game object. So what I've done, if I come down so we can see both, is first of all we created a transform which is empty, so that will just hold the coordinates of position of an object, which will all be null and empty for now. When it starts, the bird will then find the tag and assign the coordinates of the object it finds in the scene to our variable. And then in the update statement, which happens over and over and over again if you remember, we then create a line which we call target, and it's from the position of that transform, so here, gets those coordinates, which is why we needed a vector 3, because a vector 3 has an x, y and a z. So by going after the target focus position, it will tell us an x, y and a z value. Then we need to take away the position of the bird and get hold of the transform of the object that the script is attached to, which is the bird, so it will get the actual location of the bird's position, and it will then go after the position and assign it there. And therefore we've drawn a line from here to here. Now, a way that we can actually test this out is by using the debug command. So what I want to do is I want to debug the distance for this target variable. Now, the way that I do that is by going after the target itself and then returning something called its magnitude, which tells me the length of the line drawn, the vector between the two objects. There we go. So if I save my script, what that will then do is find the bird on the scene, get its position, and then offset it against our own position and tell me the distance between the two objects, and that will appear down in the console. Oh, hang on a second, we have a mini error. It's saying that we can't convert the game object to a transform. Sorry, slight mistake. I need to actually go after the transform. What this has done is grabbed hold of the object, but then we need to go after the transform of the object in the inspector. And it's still red. Find object with tag, not objects, as there's only one. So apologies for that, just a slight correction to the code. And now, after saving that script, the little circle will update and this will disappear and all will be well. There we go. Okay, so I'm going to open the console and press play, but rather than switch to the game, I'll put the scene back on for a second. Okay, and if we scroll down, where's our bird? There we go, there's the bird. Although it's invisible because the AR camera has hidden the actual bird object, but it's still on the scene. It's just inside the clone, or waiting to be in the clone when we actually spawn the game. Now, if I click on the target focus, you can see it's here. And down here, look, in the console, in the update statement, the distance is 22 grid units across. Now, if I grab a hold of the target focus for a second and just move it away, now look where the bird is. There's the bird. Here's the target focus. I'll just move it away and watch this number increase. There we go, look. So you can see that by going after the target focus, the bird script has found the object, and because I debugged the magnitude, which is the length of the line drawn between the two objects, then on the update statement, just like we did earlier in the C# script, it's updating and debugging on the fly. So that's how we can simply test that the script is working as we want it to. Just go back to the top level and drag my script into the scripts folder. While I'm here, I'm also going to grab the terrain and pop that into the models folder, just to keep things nice and neat. Okay, so here is the target focus. Here's the bird. Now what do we do? Well, we need to make the bird look towards the target. So because we can add code here that tells the bird to look at the target, if I move the target, then the bird will automatically rotate because the code will be in the update statement and tell it to basically follow the target around the scene. Okay, so this script is attached to the bird, and if we look at the bird for a second, there we go, bring both into shot. While the bird's selected, the bird has a transform. This script is on the same game object, so we can simply go after the transform. And there's a built-in function called lookAt, and it wants a vector 3, so it wants a position to look at. Well, let's get it to look at the target focus transform. So lookAt target focus, there we go, transform, and save the file. Now when I press play and switch back to the scene view. Here we go, here's the bird, here's the target focus. If I just zoom out slightly, we can see the box collider, and it's tilted the bird upwards, which basically means that the box collider here is above this bird, so it's getting ready to fly upwards. Now if I were to grab hold of the target focus and move it over here, watch what's happened to the bird as its box collider. It's turned to the left and it's looking this way. So watch this edge here. I'll grab the target focus, I'll move it back over here, click on the bird again, and now the bird will have turned across and look this direction. It's a little bit tricky not to see it with the AR, so I'll do that in a second. But you can see, just by looking at the target focus on the bird, then we can see these two actually moving around. Well, I'm moving the box around, the bird's following. So now what we'd need to do is get the bird to actually pursue the box and go towards that. So we have a line already drawn in this imaginary world for the bird to follow. So let's get the bird to do it. Let's come out of play mode. By the way, while you're in play mode, any changes that you do are not saved. So if I press play, move the cube all over the place, and then come out of play mode, then nothing's saved. It will go exactly back to where it is. Now, a good little tip as well, in the preferences of Unity. On a Mac, that's Unity Preferences. On Windows, I think it's Edit Preferences. But what you can do is you can come down to the colours, and one of these is the play mode tint. So if I just make this kind of a dark blue, like so, this is a quick reminder for me when I press play. Can you see everything goes blue? That's how I know I'm in play mode. Okay, now that was a little bit too dark, to be honest. Colours, let's just bring that up. Something more like that. Yeah, there we go. So we can still see everything, but it's easily recognizable that I'll be in the play mode at that point. Okay, so now let's get this bird moving. So what we're going to do is we're going to use a function called translate. And that's an inbuilt Unity function that will actually move an object along the axis that we choose and go after the target. Okay, they were both moving for a second then, by the way, because they were both selected in the hierarchy. Okay, so let's jump back to the script and let's get the bird moving. Okay, so what I want to do is I want to first decide how fast I want the bird to move. So for that, we're going to use a float, which I will call speed. Now, the way that I want the game to actually work is when you press play, when we actually are on the mobile device and we trigger off the augmented reality experience by viewing the image target, I'm going to get the code to randomly spawn a bird. Now, when you shoot the bird, it will then respawn a new bird, so that in a random location, and then it will chase after the target again. But to make the game a little bit of fun, I'm going to fluctuate the speed of each bird. So if you shoot a bird, the next one could be a lot faster or a lot slower. So the way that we're going to do that is we're going to choose a random speed. So random dot range between a minimum and a maximum number. So let's go for a random range of about 15 and let's say 30. Now we can always adjust these if they're too fast, simply by editing these numbers, and that's a way that you can edit the difficulty of the game. So the first bird could be 15, the second bird could be 18, 25, 30, 17, and it will change every time the bird is spawned, every time we shoot the bird, and it will make the game a bit more fun. So all we have to do now is translate our transform towards the target. So here's the bird, here's the target. Let's make the bird move along this line towards the target. So let's get the transform attached to this game object, the bird, And let's translate. There we go. And it expects a vector 3. So I don't really want the X and the Y positions to be moving around too much. So I'm going to set that to be 0. But I want the Z axis, which is here, the Z axis, that's the way that the model is facing. I want that to move based on the speed here. So the way that we're going to do that is we're going to get the Z to move this random amount between 15 and 30 on the Z. And the way that we're going to do that is by multiplying it by time dot delta time. Now that basically is the inbuilt timer that the game has run in seconds. So when I press play, be 1 second, 2 seconds, 3 seconds, 4 seconds. So the bird will not move left or right on the X, nor will it suddenly shoot up or down on the Y, but it will move along that Z axis towards the target. Now we don't have to worry about turning the bird on the X and the Y axis because above we've used the look at function. So the bird will automatically constantly be looking at the new target's position, and all we have to do is maintain this constant movement towards the target. Okay, so now we'll have the bird flying around. So what I'll do just to demonstrate this is I'll move the bird right back over here. Oh, it's just lagging for a second, guys. There we go. And I'll get the target focus and I'll move it right back over here. And then I'm going to press play and highlight the 2 box colliders, and you'll be able to see the bird flying towards a target. So 1 second, switch to the scene, highlight both, and there it goes, look. Fantastic. And you can see that it's now reached the target. So if I were to grab the target and move it right over here, then the bird is flying across again, and we can see the box collider has moved. So let's just watch that again from a different location. I'll come up a little bit higher and I'll move this target even further. Oh, sorry, move the bird back. There we go. So there's the target, there's the bird. Let's press play, switch to the scene again so we can see the colliders. And look, the bird is moving on that axis. If I move this over here, then the bird is turned towards the target. And it's working exactly how we want it to. The script is running, and on the update, it's always looking at the target focus, and it's translating across the Z-axis at a random speed that we've decided, and multiplying that by seconds. So I'll just put the target focus back again and zoom down to the scene. I'll move the target over here. I'll put the bird over here. And there we go. That's it for this video. I'll see you in the next one.